Hello and welcome back to my shop, or in this case my computer room. So I've been playing around with this 3D printer here. This is a Creality CR10S, and the reason why I settled on buying this, like I said in my last video, was about shipped to my door $451. The reason why I actually chose this particular printer is there's a very good following out there for this printer. There are a lot of forums, a lot of people with fixes for issues that they have this, upgrades for this. It's a very user-friendly computer. It's kind of an open source design. Everything on here is pretty much off the shelf besides the actual circuit board, the actual logic board, the motherboard in here, and this screen. Everything else in here is pretty much off the shelf parts. Stepper motors, this is just aluminum extrusion that this runs on. Everything here can be bought off the shelf. You don't have to go through Creality to get it if anything breaks. Now that being said, since everything is off the shelf, it's kind of built to that $450 price point, meaning that this is only aluminum extrusion. So there are definitely some shortcuts here that can be improved upon. But like I said, one of the reasons why I purchased this particular printer is bang for your buck. It's the best I could find. It had the biggest printing envelope for the smallest entry-level price. So I've been printing a ton of upgrades for this. Some of them are going to be electronic upgrades, and a lot of them are going to be just physical hardware upgrades. So I've been printing a lot of brackets and everything else like that, so we'll just go over what we're going to do. One of the biggest failings of this unit is the fact that it is made out of off-the-shelf aluminum extrusion, and you can see it just has this giant gantry frame. That being said, the only thing that indexes this to be 90 degrees to this base is the cut on the bottom of that aluminum extrusion up against the top of the other aluminum extrusion. So there's a good chance of this gantry being tilted. Also, it being so tall, when this print head gets up here and starts whizzing around, a lot of vibration gets transferred into this bar. That right there, that wiggle, not that, but that wiggle that you see right there, so you can wiggle that back and forth, that could get translated into your part. So one of the major upgrades that we're going to be doing to get rid of that and be able to adjust this gantry frame into perfect parallelism with itself, or to be parallel with itself, is to add these brackets. So these brackets, one set of these is going to be going on the bottom, and the other set on the top, on both front sides. And between them will be a threaded rod, and that'll be adjustable so we can bring these parallel to each other and perfectly perpendicular with this bottom frame. Right now, when we get up close, I'll show you we're not parallel, at least on this side. This side isn't too bad. This side's pretty terrible. The other thing we're going to do is, off of this frame, we're going to be adding a Logitech webcam, and that'll sit right here, and that'll allow us to view the print when we install our Raspberry Pi controller. This is a case that I printed for it. Unfortunately, I forgot to buy screws for it, but right now it's in there. So we're going to transfer Octopi, which is a operating system basically for this, to this Raspberry Pi. This Raspberry Pi is going to act as our computer that will be controlling this, and will also allow us, since this has onboard Wi-Fi, will allow us to look in on our prints wirelessly through our phone or another computer hooked up to our network, so we can see if the print is failing. So if I get something that's going to print for 12 hours, I can set it to go. I can leave home. I probably wouldn't leave this running without somebody in the house, just because I'm paranoid about fire. But like, if my wife is home, I can leave this running. I can check on it periodically to see if the print has failed, and I can remotely stop it from my phone. I can also send prints from it from my phone to the printer. Another upgrade we're going to be doing is we're going to be changing out the fans. Now, the only problem I've had with this unit since I've had it is these fans suck. They're terrible. Even already, there's 3 fans in this power supply unit. There's 1 fan in the actual power supply itself. There's an exhaust, there's a little circulator fan, and there's an actual fan on the power supply unit itself. that one already started making a hollow noise, and I actually had to take it apart and put a little drop of oil on it to get it to quiet. This hot end cooling fan that actually cools the extruder end here, that's starting to make a ticking noise. So those fans are going to be replaced with quieter fans, better fans made by Noctua. In the process of that, we're also going to upgrade the ducting, so that on the side of this, and we'll get a close-up of this later, on the side of this here, there's a little blower that blows on the plastic as it's coming out, and that's how it solidifies it, and that's what will allow you to kind of bridge gaps as that plastic goes and allow the plastic to solidify and hold its form. It's kind of a crappy design. It's a really, really small duct, and it's only on the right hand side. There's nothing on the left. So we have a better duct here with a better fan mount, and these together are going to allow two ducts to go in and cool our pot, still using the stock fan here, the stock blower on the side. Another thing that I'm going to do also is replace these mounts for these servos. The servos are connected directly to this frame, which introduce a lot of the motor vibration into the frame and also a lot of noise into the whole system. I can hear this running with this door closed in my bedroom, which is down the hall. I can hear the servos, especially when they fast track across. You get that high, like, zzz, you get that noise. I can hear that in my bedroom. So to try to quiet that down, I have vibration dampers that are going to go between the motor and the frame to try to quiet those down a little bit. And the same thing with the fans too. The fans I have coming are going to be a lot quieter. So now what we're going to do is basically the mechanical mods. We're going to see my fans aren't in yet. They should be in later this week. And I also have an LED light that's going to be on a frame up here that is just going to be made out of an LED strip and a power supply. Those I'll do when those come in. For right now, I want to do just the mechanical modifications to this. So the vibration eliminators and the brace, and then I might do a whole separate one of just the Raspberry Pi, downloading that, putting it on, installing that, and getting this to work off your phone. And then the third one will be a fan mod. And then we're pretty much done. I'm happy with where this is going to be, and we can start making some serious parts for either my machines or anything else we can come up with. Okay, so in an attempt to quiet these motors down, and it's not the actual physical noise of the motors that's really loud, it's this motor vibrating into the frame, which is then vibrating into your table, acting as basically one giant speaker, amplifying the noise of this motor. And also any vibration that comes with this, of the starting and stopping really fast, going back and forth, is also going to be translated into vibration in the frame. So to take as much of that out as possible, we're going to be adding Nema 17 motor dampers, which is basically just two flanges connected by a rubber gasket. So we're going to place this on the motors. To do that, we need to take this motor off. So first we're going to take the belt off. So I'm just going to loosen these two Allen set screws here. I'm going to remove this pulley. Should have enough slack to do it. There we go. Now another thing, if you notice, what they basically use is two flanged bearings sandwiched together as an idler pulley. They don't use a toothed bearing idler pulley there. So I was looking into getting those, but I'll be honest with you, I don't think it's that big of a deal having it like that, instead of having it toothed as the belt is toothed. So it might be something I'll do down in the future, but for right now, we're going to leave well enough alone. Now if you look at the mount, I don't know if you can tell, one hole in the mount is threaded, one hole is, these are threaded here, well, this one and this one are threaded, and these are through holes. So the through holes go on the motor. Okay, so just to show you what these braces is going to prevent, I have my machinist square flat against here. It actually fits perfectly in between these two stripes, and flat against here. Now if I take my flashlight here on my phone, if I can get the angle right there, you can see light through that. So let me just, you can see how much that's off. So basically what needs to happen is, if I pull this towards me, you can see that gap widening. You can see that moving around. So that brace is going to hold that steady, and I'll be able to get rid of that gap and make this perfectly perpendicular to this base. Okay, so we're ready to mount our brackets. So I'm going to pull this cap off the end here. I'm going to tap that hole for 5mm. Okay, and we're going to get little 5mm T-nuts. I have a little assortment here. So we're going to get a T-nut, and there are different size screws, and the instructions and everything tell you exactly what sizes to get and what sizes to use where. And that's all I'm following. Okay. Okay, that one's actually locked in there nice. This side's locked in there nice. And then this side's locked in. Let's give him a nice little snug. Okay, and I'm going to do the exact same thing with that bottom bracket, and it's going to sit vertically like so. So I'm going to do that off camera, and then we can put the bar in. Okay, so the two brackets are on, and what we have is these thicker pieces here. Alright, the nut goes in first, and the washer goes on second. And it sandwiches that all together. And then in these other ones, same thing, but it'll have an open back. So now, these brackets, what happens is they slide into the slot like so. One of the longer screws here goes through. And then on the back, the nut gets captured in the nut-shaped hole that's there. Alright, we just tighten this down. We don't want to over tighten this yet. So we still need that loose, and we're going to do the same thing at the top here. We're going to take our larger nut and washer combo here, and we're going to get this on. Okay, I'm going to get our smaller nut, and we're going to put it into there. And we're just eyeballing roughly how long here. Alright, that looks pretty good. What I'm going to have to do, I'm actually going to have to take that off real quick. I have to put a dab of super glue on that one. So now what I'm going to do is I'm going to check my gap here. And I'm going to tighten this. Until that gap is gone. So let me get a light source behind this. I'll keep tightening this and pull that frame into compliance. What I'm going to do is just put a dab of super glue on that nut, and that'll make sure that this doesn't fall off. Okay, so we got our braces in place. Now the one last mechanical upgrade we're going to do with this for now is going to replace the Bowden tube, the little tube that connects the extruder stepper motor to the hot end. We're going to replace that with this. This is called a Capricorn tube. This has less friction than this original tube, little vinyl tube here, and that will allow us, if we ever wanted to print flexible filament, that would help us out with that. So it has these little push connect fittings like water fittings, so you just push the little plastic ferrule thing in there and then pull out. At least that's what's supposed to happen here, and that is exactly what is not happening. Probably because it's buried in there. Okay, so we basically have the mechanical modifications done. The next modifications are going to be electrical. We're just going to put the LED light up here, which I'll probably just do off camera. It's just an LED strip. I'll probably just show it. The subject of the next video will be more on programming that Raspberry Pi to act as a controller for this and integrating it with a webcam. And then after that, when my fans come, the fan mods and duct mod will be another separate video. So hopefully, hope you guys kind of enjoy this series. Give it a thumbs up if you do. Let me know what you think, and if you want to see more of this printer. But the braces and everything are in place. This side here was actually pretty perpendicular to the base. It was actually pretty good. This side was definitely out, and now there's zero wiggle in this. I mean, I'm pushing pretty good, and I'm moving the whole thing. I'm not moving the top at all. So that'll give us more stability and a lot less shaking that will show up in our prints, especially if we ever do anything really tall. So for investment in basically some threaded rod and some nuts and bolts, the only other thing you have is printing out some parts, which is actually pretty cheap. A 1 kilogram, so what's that, little over 2 pound roll of filament. Now let me show you here. So 2 pound roll cost you 20 bucks. This one is almost full. The only thing I printed off of this was that fan shroud, so you can see how far up that is on the spool. Everything that you see that's black on this, plus the bracket for up here, and plus the cover for the Raspberry Pi, plus a lot of, I actually printed out one extra bracket and had a lot of mistakes along the way, and that's what we use for filament. So maybe a third of a roll. So if you go a third off of 20 bucks there, plus maybe hardware store stock, maybe 12 bucks, 12, 15 bucks, you pretty much have this here for about 20 bucks. $20 will get you this frame just about if you print it out, not including electricity and time. So pretty good mod, definitely more stable, and like I said, if you guys want to see any more of this, give a thumbs up and comment down in the section below. Thanks for watching. We'll see you in the next video.